Welcome viewers. In this video we will see the solved problem based on the RC series circuit. Resistor and capacitor is connected in series. For that we are going to see the solved problems. First we will go to the problem 1. A capacitor having a capacitance of 10 microfarad is connected in series with a resistance of 120 ohm across a 100 voltage 50 hertz supply. This resistor and capacitor are connected in series across this supply. We need to find the current, power, phase difference between current and voltage and supply voltage. We need to find this parameter. So the given data is capacitor equal to 10 microfarad, that is 10 into 10 to the power minus 6 farad. Micro means 10 to the power minus 6. The R resistor value is 120. The voltage, supply voltage is 100, the frequency is 50 hertz. So before going to find the value, first we will find the inductive reactance, capacitive reactance, Xc. Xc equal to 1 divided by 2 pi Fc. So substitute the value 1 divided by 2 pi, the frequency is 50, the capacitor value is 10 into 10 to the power minus 6. So by simplifying this we got 318 ohm. The capacitive reactance is 318 ohm. Now we can find the impedance of the circuit. Impedance is square root of R square plus Xc square. So the R value is 120, Xc value is 318. Just now we calculated. So by simplifying this we got 340 ohm. So the impedance of the circuit is calculated. So by using that we can calculate the current. Current I equal to V divided by Z. So V is 100 voltage. The Z is calculated as 340. So 100 by 340, by simplifying this we got 0.294 ampere. So current flowing through the circuit is 0.294 ampere. Now we will go to the phase difference. So phase difference, the formula is available. Pi equal to tan inverse Xc by R. From the phasor diagram this formula is derived. So Xc value is 318. We calculated 318 divided by R value is 120. So tan inverse 318 by 120 is we got 69.3 angle degree. 69.3 degree is given leading because of capacitive circuit. Capacitor is available. So in the capacitor the current is always leading the applied voltage. So that this angle is leading. So from this pi value we can easily calculate the power factor. So the angle between the current and voltage is 69.3 with a leading. So power factor is nothing but cos pi. Cos pi equal to cos of pi value. Pi value is 69.3. So cos of 69.3 is nothing but 0.353. Is also leading because of capacitor. Current is lead in the capacitor. Now we will go to the power. This is average power. P equal to Vi cos pi. V is 100 voltage. The current is 0.294. We calculated. The cos pi value is 3.53. So by simplifying that we can get the value of P. P equal to 1010.38 watts. The average power is calculated as 10.38. So now we calculated all the values: current, phase difference, power factor and power. Now we will go to the second problem. The resistor R in series with a capacitor C is connected to a 50 Hz 240 voltage supply. Resistor and capacitor is connected in series, that is connected across the 50 Hz 240 voltage supply. The question is find the value of capacitor so that resistor R absorbs 300 watts at 100 voltage. We need to find the capacitor value. The other values are given as the resistor is absorbing 300 watts at 100 voltage. And also we need to find maximum charge as well as maximum stored energy in the capacitor. So this is the question we need to find. So the data available is V equal to 240 voltage, frequency is 50 Hz. The power absorbed by the resistor is 300 watts at a voltage of 100 voltage. So first we will find the parameter one by one. First we will find the voltage. Based on the series circuit, total voltage equal to sector sum of voltage across resistor plus voltage across capacitor. So V square equal to VR square plus VC square. Now we need a VC square. So this VR, bring this VR that side. So that VC square equal to V square minus VR square. Now take the square root on both sides. So that Vc equal to square root of V square minus VR square. So V square is given 240. Total voltage is 240. The voltage across the resistor is 100 voltage. So by simplifying this, we got 218.2 voltage, 218.2 voltage. Now we calculated the voltage across the capacitor. Now we'll go to the power, because power is given. Power absorbed by the resistor is 300 watts. Based on that, the power equal to VR into I. Power absorbed by the resistor equal to voltage across the resistor into I. Power absorbed by the resistor is 300. The voltage across the resistor is 100 into I. So bring this 100 in the denominator, so that I equal to 300 by 100, it is 3 ampere. So the current is 3 ampere. Because of series circuit, the same 3 ampere is flowing through the capacitor as well as the resistor. So from that we can find the Xc value, capacitive reactance. Xc equal to Vc by I. Vc is 21.82. That is voltage across the capacitor. Just now we calculated. The current is 3 ampere. So by simplifying, we got 72.73 ohm. Capacitive reactance is 72.73 ohm. This capacitive reactance, the other formula is available. The Xc is nothing but 1 divided by 2 pi Fc. That is equal to 72.3. So we need this C value. Bring this C in the numerator, 72 point in the denominator. So that C equal to 1 divided by 2 into pi into the frequency 50 Hertz, and this Xc value is 72.73. So by simplifying this, what we got, 43.77 into 10 to the power minus 6 farad. That can be written as 43.77 microfarad. 10 to the power minus 6 means microfarad. So now we calculated the capacitor value. Now we will go to maximum charge and maximum energy stored. So the maximum charge Qm is nothing but capacitance multiplied by maximum Vc. This capacitance value already we calculated, 43.77 into 10 to the power minus 6. So we need a value of Vc, maximum Vc. So we will find maximum Vc first. Maximum Vc equal to root 2 into RMS value of Vc. So that is equal to root 2 into RMS value of Vc is 218.2. That also we calculated. So by simplifying that, maximum Vc equal to 308.6 voltage. Now we calculated the maximum Vc. Now substitute this value here. So by simplifying this, we got maximum charge is 0.0135 coulomb. Now we will go to the energy stored. The energy stored is half C into maximum Vc square, half Cv square, that is maximum Vc square, maximum energy, so that here we are using maximum voltage. So half into C value is 43.77 into 10 to the power minus 6. The maximum Vc, just now we calculated 308.6 maximum Vc square. So by simplifying, we got 2.08 joule. So we calculated all the parameters. So in this video, we discuss about the solved problem based on the RC circuit, part 1. Thank you.